Hi, welcome to the Shiko Math Practice Lab, learning through practicing. And we are in the units talk about the limits, continuity, and differentiability. This is the second video on the practice number 7. We are taking looks the derivative and the rate of the changes here. Okay, we did several problems on our first video. Now let's go ahead and take a look at what are the remaining problems we can, related to this topic, and we can try to work on that. Okay, so here, let's take a look at these ones here. So for these ones here, we have a functions here, and then we want to find the values of try to rearrange those numbers. It's G prime, -2, G prime 0, G prime 2, G prime 4. Okay, so remember, so the purpose for this problem is just want to test us. It's like we know the derivative is the slope of the tangent lines here. Okay, so now let's take a look at G -2, right? So this is the G -2. So that means you find the tangent line at this point. And then you see this is my tangent lines, right? Okay, so now let's take a look at G prime 0. I'm going to have a different colors. So G prime 0 is here, right? So that means I'm doing, okay, so here, this will be my G prime 0. Then G prime 2 is here. This will be somewhere like here. Okay, and then the last one is G prime 4. 4 is here, right? So then I will have this 4 different tangent lines here. So I know the derivative is the slope of the tangent line. So that means if the lines go upward, I know it's positive. So I know this one definitely is positive, the red ones, right? Then this one is definitely positive. And this one is definitely positive. Then the blue ones here definitely is what? It's negative because it's go backward, right? So downward. So I know the first thing I know the G prime 0 going to be the smallest one. It's going to be less than 0, right? Because, this is negative slope. And then let's take a look here. So we have 3 positive lines. This red one, black one, and this green one. Obviously, the black one is the most flat compared to 2. So from here, you see the red one looks is a little bit more steeper than the green one, or, like right now, we just kind of eyeball that. So, right. So we said, okay, red one maybe is the most steeper one. And then the green one and the black one is the flatter one. So that means the slope is less, right? So it's less. So, but it still is a positive. But this slope going to be less than G prime 2. And this one is going to less than G prime -2. Right, so for the 2 and -2, it's really kind of depends on how you eyeball. You might have a different idea, but that's fine. That's not the point. Is just want to tell you, show you, the derivative is the slope of the tangent lines here, right? So that's how do you identify which number, what is the values here. Okay, let's take a look at the same one, similar ones here, right? So the graph of the function f is given. I want to find the average rate. Remember the average rate we already did on the first, the first video. So we say is the what? X plus h minus f of x and the h is here, right? Okay, so the first ones here, they say the average rate on the functions when the function is from the 20. So here, this is 20 to 60, right? So 20 to 60. 60 is somewhere here, 20 is somewhere here, right? So it's a little bit less than 400, 800. So this ones here will just be what is f of the what? 60 minus f of the 20 and divided by how many units in between here? Is 40 units, right? So in here, now you will see from here to here, well, it's approximately, it's like a 400 here. Okay, so it still is eyeballs here. So we'll say this is the 10. All right. So now let's say identify which interval the average rate of the change f is 0 here. Okay. This is a very good question here. If you want to find the average rate of the change is 0. Because this is how do we define the average rate of the change. If equal to 0, what's that mean? That means the top has to be equal to what? The top has to be equal to 0, right? So that means you are looking for the graph to see which interval then you will have the same values here. So you kind of see here 0. So like, oh, looks like this one and what? Look like this one and well, okay, so this one's, you know, you can see maybe this one. All right, so you can see, hey, when the 0 is here, okay, so they touch this line, so this one's here, right? So we probably can estimate, so that means in here, I'm having the same endpoints, okay? And so this is the same endpoint. So that means what is the, so maybe so the here, I know this is the 0 and kind of like the 57 or 58 is the eyeball slat. Okay. So now the next ones here, they say which interval gives a large average rates of the change. So here you will just use the same ways here, right? So for 40 to 60, the average rate of change is just f of the 60 minus f of the 40, and then you divide it by 20s, right? And so this one is you're looking for f of the 60 is here, right? So f of the 60 is here, f of the 20 is here. So the then divided by 20. So this one's here is approximately, so this is 25. And then the f of the 40 and the 70. So you say this is the f of 70 minus f of 40 divided by how many is here? 30s, right? So you look here. So this is a kind of the approximately 23 over 1/3. Okay, so which one have a large rate of the changes here? This one's here. Okay, and okay, so now for the part D is here, let's say, hey, compare the f of the 40 to the f of the 10. Here, f of 10 is here. So we know how to do that, right? So for this one's here, so let's take a look at this province here. So this province here, the f of the 40 is about 200. F of the 10 is about 400, right? So it's 400. 40 to 10 is 30s, right? So then you can calculate that. So this will be negative like 200s over what? 30s, right? So it kind of like equal to -6 about 2/3. Okay, so what's that mean? So here they want to ask is what is the value? What is that means geometrically? So we know that geometrically, so just like we did before, this is a 40 and the 10s, right? So 40 is here, 40 is here, and the 10 is here. So this one's really, if you connect these 2 points, right? So it's really the slope, right? So we know that the geometric this means is the slope of the second line, right? For this function, connect these 2 points. And we talked this before, so it's kind of like a review what we did before. Okay, now let's take a look at number 20. Find the equation of the tangent line to the graph at x equal to 5 if g phi equal to -3 and the g prime phi equal to the 4. So find the line. So in the algebra, we know the line, we have a point slope formulas, right? So if you give me a point x1, y1, you give me a slope. So how do I find the line? Is 1 minus y1 is equal to the slope x minus x1 here, right? So this is the same way. So let's say, okay, x equal to 5, g 5. So what is this information tell me? So this information tell me the x5 and the g5, that means this is my point, it's 5 and -3. Okay, then they also said, hey, g prime phi equal to 4. So we know every time you see the derivative, so that's the slope of the tangent line. So what is this one tell me? This is my slope, right? So this is my slope here. And now I know I can apply it. So I will say y minus y1. So it's y plus 3 is equal to the 4, the x minus 5. Correct? So if you simplify that, so you will be equal to y equal to the 4x minus 20. So the minus 23 is here. Okay. Okay. So now in here, okay, so the last one's here. So let's say if the tangent line of y equal to the f of x 4, 3 also passing through the point 0, 2 here, right? So that means, you have some tangent lines here, right? And this tangent line also passing through the 0, 2 here. So I want to find F4 and F prime, F prime 4, okay? So this one is interested here. So they say that at the tangent line 4 and 3. So obviously, so what is F4? That means x equal to 4, right? So this is x and this is y. So this one is easy. So what is this one's here? This is 3 here, okay? So now I'm going to find the f prime 4. What is the f prime 4? That's the slope of the what? The tangent lines here, right? How do I do that? Oh, because this line passing through these 2 points, the line passing through 4, 3 and the 0, 2 here. So I know the slope here is what? The slope is the rise over runs, right? The rise is 3 minus 2 is 1 over run, so it's a fourth, right? So it's 1/4. So because this is the slope, so I know the derivative of the 4 is what? It's 1/4. Okay, very, very good problems here. Okay, so that's the problems here. Okay. All right. So this number 28, I think we all know how to do that. So basically, you want to find the g prime 1 and that's the derivatives, right? So then you use the point. So this is your point, right? So you need to find the g prime 1. Then what is g prime 1? We say, hey, g prime 1 is just the same things, right? So it's a limit x approach to 1. Then you have x minus 1, gx is x4 minus 2. Then minus f of 1, so what is minus half? Negative 1, right? Because g to the 1 is equal to what? Is equal to 1 minus 2, is negative 1. So that's what you have here. Then you have a limit x approach to 1. Then this is x minus 1, and this is x4 minus 1. So how do we do that? Factors, right? Okay, so you'll be able to factor. So this is x minus 1. Then this is x squared plus 1, x minus 1, x plus 1. All right, and then problem become easy. So x minus 1 cancel. And then when you find the limit, what is this limit? 1 plus 1 times 1 plus 1 is 4. So this is, what is this 4 here? Because this is what? This is the derivatives, right? So we know the derivative is what? Derivative is slope. Then I can use the slope and the intercept form again to find the tangent line. So I will say y plus 1 is equal to the 4, the x minus 1, right? So you can simplify it. So y equal to the 4x minus 5. Very easy here. Okay, now the last set is will show you, kind of try to make sure you fully understand, when we define the derivative based on the definitions here, right? So now let's see, they say find the function f and the a. All right, so let's try to put our formula here together. So this is limit. If it's h approach to 0, so you will have h, then this is a plus h minus f of a, right? So this is one way, or they have a different way. So it's an x approach to a. So this is x minus 2, then this is f of x minus f of a. All right, so obviously the second part, this one is a lot easier, right? Because when x approach to, I'm sorry, here I should say x approach to a. So when x approach to a, and then this one is a lot easier to identify. So now let's take a look. Let's see these ones here. So this is x approach to 2. So this is f of a equal to what? 2. Then the first items here, this is x to the 6th. So I know this is f of x equal to the x6, right? So this one match, right? So 64 is 2 to the 6th power. All right, so this, so when they do the second formula, it's a lot easier. Okay, so now let's take a look here. This is x approach to 1/4. Oh, obviously a is equal to 1/4. And what is my f function? The f function is equal to the 1 over x. Cool. All right, now this one here is also, let's see here. This is the theta approach to pi over 6. Oh, okay. So I know my a is what? My a is pi over 6. And what is my f function? F theta is the first one. So it's a sine theta. Right? So that's what I said when, when you use the second formula is easier if you see the x approach to certain number, so you know exactly what limit we are looking for. Okay, now let's take a look at this set formula, a plus h, f of a, h approach to 0. Okay, so now in here, so this one's here. Okay, so let's be careful here. So this is limit h approach to a. So look at the formula, it's a plus h. So a plus h. All right, so this one I say, oh, all right, I identified a is equal to 9 based on my definition. And then in here, this is f of a. So what type of the functions, and then here you have square roots. So I know the f of function has to be what? Square roots, right? Because you put a 9 here, will give you 3. Cool, okay. Now, let's take a look, the next one's here, right? All right, so now this one's here, this is h approach to 0 here, all right. Now, let's take a look here. This is, all right, so this is h. So we want, based on the formula, right there is a plus h. Oh, okay. So what is my a here? My a is negative what? Negative 2. And then now in here, I have e to the -2. This is my FA, right? So, so I know my f function is what? E to the what? X, right? So when you plug -2s here, it's -A. Great. Okay, now let's take a look at this one here. Okay, so this is, right, so it's h plus x, right? So let's see here. H plus A, okay, H plus A, okay, looks like A is what? Looks like A is the pi. Okay, so what is my f of x here? F of x, well, f of x looks like a cosine, right? So, okay, let's try. So this is a cosine x here. Okay, so right now I want to verify is the typical is minus f of a, right? So the based on my definition is a minus here. See here, right? It's a minus. Why here is a +1? And but then if you say, okay, let's see here, this is true or not. So this is f of a, so it's f of pi. So it's a cosine pi. So what is cosine pi? It's -1. Oh yeah, so it's a minus -1. So that's why it's a plus. So I know I did this correctly. All right. Okay, that's it. So the remaining, okay, so the remaining two problems here determine whether the differentiabilities, right? So x sine x and x squared sine x. And these two problems we discussed at the same unit. We did these two problems at the practice set number 6. Okay, so this is the practical set number 6 video. So you'll be able to go back there, go back to the practice set number 6 and to see how do we decide the f prime 0 exists or not. Okay, and that's it. That's it for this topics here, the rate of the changes and also the definition of the derivative. Okay, that's it. Okay, have a good day and I will talk to you on next assignments here. Okay, bye.